Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find the length x? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. The blue figure is a stepped L shape with one corner cut away, and the unknown x is the horizontal side CD at the bottom. Everything we do will be aimed at recovering that one length. The blue stepped region A, B, C, D, E, E, F has an area of 36 square units. That is what is left after the corner notch has been removed, so it is smaller than the full rectangle we are about to build. The red right triangle AEF sits against the missing corner and has an area of 9 square units, with its right angle at F. Keep that 9 in mind, because the notch we cut is built out of copies of this triangle. The left edge segment BC measures 9 units. This is one side that the length x will multiply once we square the figure off into a clean rectangle. Mark the top right corner H directly to the right of A and in line with D. Now draw segment A to H straight across the top side and segment H to E down the right side, so the corner H is a perfect right angle. With that corner filled, the outline BCDH is now a full rectangle. Its area is base segment BC times height segment CD, and that is the quantity we will pin down two different ways. The only piece we added is the small rectangle HEEFA in the top right. By construction, it is exactly the full rectangle minus the blue stepped region. So if we can measure it, we can relate the two areas. The diagonal AE, which was already the hypotenuse of the red triangle, cuts the little corner rectangle HEEFA into two right triangles. That diagonal is the bridge between the notch and the 9 we already know. To the left of the diagonal is the red triangle AEF, the bottom left half of the corner rectangle, with its area of 9. That is one of the two halves accounted for. To the right of the diagonal is triangle AHE, the top right half we drew in. We now need its area to finish measuring the corner. Our first insight is this. In a rectangle, opposite sides are parallel and equal, so leg segment AH equals leg segment FE, and leg segment HE equals leg segment AF. The two triangles are built from the very same pair of side lengths. Two matching legs around equal right angles make triangle AHE congruent to the red triangle EFA. Congruent triangles have equal area, which is exactly what we need next. Because it is congruent to the red triangle, the filler triangle AHE also has area 9. Both halves of the corner rectangle are now 9 each. Adding the red 9 and the filler 9 gives the corner rectangle HEFA an area of 18 square units. That is the size of the notch we filled in. So the full rectangle BCDH is the blue region plus the red triangle plus the congruent filler triangle. Every square units of the rectangle now belongs to exactly one named piece. Putting in the known areas, that is 36 plus 9 plus 9. Each number came straight from the givens or from the congruence we proved. A second insight now finishes the structure. 36 plus 9 plus 9 is 54. So the completed rectangle BCDH has an area of 54 square units. That is our first way of writing the rectangle area. The same rectangle also has area equal to its base segment BC times its height segment CD. This is the second formula-based way of writing that identical area. The base segment BC is 9, and the height segment CD is our unknown x, so this second expression is 9 times x. Now both expressions describe the very same rectangle, Since the two expressions are the area of the same rectangle, they must be equal, giving 9 times x equals 54. One clean equation now holds the height. To isolate x, divide both sides by 9. The 9 on the left cancels, leaving x by itself against 54 over 9. 54 over 9 is 6, so x equals 6. The height segment CD of the original stepped figure is 6 units. Checking backward, 9 times 6 is 54, which matches the rectangle area exactly. The value 6 is fully consistent with the blue 36 and the two 9s. So the answer is 6. The final answer is 6. If you found another construction, share the key move in the comments. Thanks for exploring geometry with GeoMethod.